Even in ancient times, people knew about the existence of electricity. Lightning, of course, is so dangerous and unpredictable that we wouldn't expect people to know much about it other than to avoid it. But in ancient Greece, people were already experimenting with static electricity by building a charge on a piece of amber. It's no coincidence that the Greek word for amber is electron. However, we have to wait until the late 1700s to discover how to generate and store electricity at will. First, people built machines to generate larger static charges. This led to the discovery of a method to store charge in what we would now call a capacitor. The Leiden Jar could store a much larger charge and could hold that charge for hours or days without dissipating. However, he quickly came to realize that there are risks involved in the sudden and complete discharge of large amounts of electrical charge.
He writes, "It's a new but terrible experiment which I advise you never to try. Nor would I, who've experienced it and survived by the grace of God, do it again for all the kingdom of France."
It was with an apparatus like the Leiden Jar that the Italian anatomist Luigi Galvani used to make dead frog legs twitch and seemingly come to life. He credited the movement he saw to an internal animal electricity unique to living things. Confirmatory evidence that animal movement was controlled by electrical impulses seemed to come from the ability of electric eels and catfish to produce shocks for hunting or for defense.
What? No more electricity in you? That was wrong! He still has the ability to shock again.
Another Italian scientist, Alessandro Volta, disagreed with Galvani, claiming instead that the frog's twitching resulted from the externally applied electricity and not any intrinsic electrical organ. Galvani, to bolster his original result, strung the frogs from an iron wire without any contact with the ground or external source of electricity. When he then touched the frog nerve with a copper wire, the legs still reacted with movement, seeming to prove that the electric charge was in fact already stored in the legs. But Volta was not convinced. Without an obvious external source of electricity, he now said that the source of the charge must have been the metals Galvani used in his experimental setup. In an attempt to definitively contradict the concept of some special animal electricity, Volta recreated the experiment without a frog, leaving only what he felt were the important components: two different metals and an aqueous medium connecting them. By stacking alternating layers of copper, zinc, and brine-soaked paper, Volta successfully created electricity and convincingly won over supporters to his argument. Not only that, but Volta's pile generated an ongoing flow of electricity, and this was something new. The collection of cells into a battery generated a steady current, not a quickly discharged flash as it was from the capacitors, setting the path for the new field of electrochemistry and for the electrical world we live in today. But you don't have to take my word for it. Unlike the Leiden Jar, this is definitely something that you should try at home. To build your own voltaic pile, you'll first need a few shiny pennies. This is going to be our source of copper. Any pennies will do actually, because it's almost magical how easily you can clean off the tarnish with just a simple solution of vinegar and table salt. Next, you'll need a second metal. Now, I don't have any zinc foil lying around, but I do have aluminum foil, and this will work perfectly well. Interestingly, this part would have been impossible for Volta to do. Aluminum wasn't discovered until 1825, and even then the refinement process made it more expensive than gold. It only became cheap after an electrochemical process was developed to reduce aluminum from aluminum oxide. Lastly, you'll need some brine-soaked cardboard to separate the individual cells. You can soak paper in vinegar or salt or both, or actually neither. Go ahead and test different combinations and see what happens for yourself. At this point, we have all the materials we need to assemble the pile. If you have a multimeter, you can measure the voltage you get from your battery. The voltage depends on the number of layers in your stack, so if we place the probe to measure fewer layers, we record a lower voltage. As we'll see, the specific voltage depends on the type of metal, so I would encourage you to give other metals a try if you can. Maybe steel washers instead of aluminum foil, to see what kind of voltage you can get. Galvani was wrong about animal electricity, but he was right about electrical signals being important in the control of muscles and nerves. Volta was right about dissimilar metals being important in the construction of an electrochemical cell, but he was wrong about the mechanism. Instead, we recognize that reduction and oxidation reactions, the fundamentals of electrochemistry, are responsible for the production of electrical current. One important piece of evidence for a chemical mechanism of electricity is the fact that no matter what they did, corrosion of the metals was an inevitable result of the battery's operation. Even our little 10-cent pile produces obvious formation of copper and aluminum oxides.